compounds are composed of nonmetals only. The names of these compounds begin with a prefix, which specifies the number of atoms of the first element, followed by the name of the first element, and then another prefix, which specifies the number of atoms of the second element, followed by the base name of the second element, and completed with the ending "-ide". You typically drop the prefix mono when it's on the first element. For example, N2O is dinitrogen monoxide, NO2 is nitrogen dioxide, and N2O3 is dinitrogen trioxide. The most common prefixes are mono, di, tri, tetra, penta, and hexa. Okay, here's a practice question for you. What is the name of SF6? A, sulfur fluoride 6, B, sulfur hexafluoride, or C, sulfur 6 fluoride?
Sulfur B.
All right, you guys are right.
The correct answer is B, sulfur hexafluoride. The compound is molecular with 2 or more nonmetals, so you name it accordingly. You drop the prefix mono for the first element and add the prefix hexa, which means 6, to the base name of the second element with the ending "-ide".
All right. I would love to link this on D2L, but I can't. It comes from another textbook, and there's no way for me to link it, but I wish I could. But I've put a lot of the information from it on D2L. Let me pull up what I've put on D2L for you, because I think it'll be pretty handy. This isn't what I put up. So if you go to content, this is how you find this thing. Hang on. Go to content, scroll down to exam materials, including homework. Scroll down to exam 2. Click on homework. And then you'll see this whole section called Rules on Naming Compounds and Acids. So you click on that. It's got, let me get down here to where we're talking about. Okay. So right here is the naming molecular compounds. So it's got the instructions here. So you put a prefix and then name the first element. Then a prefix and then the base of the second element, and it ends in IDE. Now this gets a little confusing because a lot of the other ones end in ITE and ATE. So just remember, if you're naming a molecular compound, it always ends in IDE, so IDE. And the prefixes are down here. The only weird rule is that you will use mono on the second half of the name, so where it says base name of second element, but you won't use mono on the first, where it says prefix name of first element. So everything else you'll use on both parts. Mono is only used on the second half. So let's see if we can come up with some practice problems to do. All right, I'll put a couple of them up here. And I can't do subscripts, so even though I put the number up to the side, it's meant to be a subscript. Oh, you didn't see them, or you don't see them. Can you not find them? You're on the page. Are you on the page that says rules naming compounds? Did you scroll down and click on the file in there? There should be a file. Do you see a file? Just in the preview. How weird is that? All right, well, I'll have to figure out what's wrong with settings there and get that sorted. That is bizarre. Let me take a look at that for just a second. All right. It's a zip file? How did it become a zip file? That is strange. Okay, give me 1 second. I'm going to show you how I went to it, and then see if that's how you went to it, which it probably is. Gosh. Okay, so let me share D2L one more time, and I'll show you how I found it. And if it's doing something strange, I'll just put everything onto a Word document and then upload the Word document instead. All right, so we're going to go to the main, we're going to start the course homepage. I'm going to click on content, scrolling down. I'm going to click on exam materials, including homework. I'm going to scroll down past the exam review, past exam 1, into exam 2 stuff. Click on homework. And then right here, this should be just a regular file. So it's got the title, Rules on Naming Compounds, and then just this. Is that not what you guys are seeing when you load it onto yours? Huh. All right. With the words. That sounds annoying. Okay, so after I'm done teaching today, I'll take all this information and I'll copy it onto a Word document, and I'll just upload the Word document, and it'll quit acting weird. I don't know why it's showing up strange for you guys. So I'll get that sorted though, so that this afternoon you'll see it. That's so strange. Okay, so I'll put it on, it'll be in the same place, but I'm going to upload a Word document because you guys should be able to see a Word document. I mean, I might even put it into a PDF. That way it'll just basically be pictures and you'll be able to see it then, even after downloading it. That's so strange. Okay, yeah, I'll put it on a PDF and see if I can get that to upload instead. All right, so let's do a couple practice examples. You're welcome, Chris. All right, so I don't have a way to do subscripts on this, so I'm just going to put the number out to the side. So instead of like CO subscript 2, it's just going to look like CO2, but that's not the correct way to do it. It's just all I can do right here. So what will we call this? So it's, yeah, perfect. Guys are quick. All right, so the first thing I look for is to see that they're all nonmetals, and they are all nonmetals. So that means that I'll use prefixes. There's one carbon, so you would expect it to be monocarbon, but since it's the first one, you don't use mono, so you just write carbon. So nothing happens to the word carbon there. And then the next one has 2 oxygen, so that's going to be di. And then the prefix of oxygen is ox. And then you end these in IBE. All right, so let's do CO. Correct. It's for the second one, but not the first. Correct. Hunter's got it. Yep. So this one, again, we're looking for all nonmetals, and that's what we've got. We've got all nonmetals. And then we see that there's one carbon. You'd think it'd be monocarbon, but since it's the first one, we just write carbon. And the second one has one oxygen. So since it's the second half, then we will use mono. And then it would end in oxide, but you don't want to have it say monoxide because it's kind of awkward to say. So they just put monoxide. You see the difference between the top where it says carbon dioxide and this one is monoxide? So they kind of put the O in there. All right, cool. It'll get worse. It's not that bad. It'll be all right. Okay. Yes, you'll have a bunch of polyatomic ions to memorize. There's a list of them on D2L under the homework setting. It says memorize these polyatomic ions, and there's a list there. There's also a table in your book. Hardest thing practice S2. Practice 2. You mean practice exam 2? Okay, yeah. All right. So let's watch the video on the naming of these binary metals. This is the next one. I've got to...
Hello?
No, not you again. Okay, that's the same one. So now I gotta go find the one on ionic compounds. Okay. All right, so this is on how to name ionic compounds. Let me make it a little bigger.
Hello. In this video, you'll learn how to name ionic compounds. Ionic compounds occur throughout the Earth's crust and are also a component of the foods that you and I eat. For example, table salt and baking soda are each composed of an ionic compound. The first step in naming an ionic compound is identifying it as one. Most ionic compounds are composed of a metal and a non-metal or a group of non-metals. For example, table salt, sodium chloride, is an ionic compound composed of the metal sodium and the non-metal chlorine. And baking soda is composed of the metal sodium and the group of nonmetals HCO3. The group of nonmetals in baking soda is a polyatomic ion that has a charge of 1-. Other common polyatomic ions include hydroxide, nitrate, carbonate, and sulfate. Hydroxide and nitrate each have a 1- charge, and carbonate and sulfate each have a 2- charge. The next step in naming an ionic compound is to determine whether the metal is one of 2 types. Ask yourself this question: does the metal, in all of its compounds, form an ion that always has the same charge, or does it form ions with different charges? The metals that always form ions with the same charge include the group 1 metals, which always have a charge of 1+, the group 2 metals, which always have a charge of 2+, silver, which always has a charge of 1+, zinc, which always has a charge of 2+, and scandium and aluminum, which both always have a charge of 3+. The metals that form ions with different charges include most of the transition metals, with the exceptions mentioned previously. Lead and tin, although they are not transition metals, also form ions with different charges. For ionic compounds containing metals that only form one type of ion, the name of the compound is created by joining the name of the cation, the metal, followed by the base name of the anion, the non-metal, with the ending I. You can find the base names of common ions in the table in your book. For example, NaBr is sodium bromide, and K2S is potassium sulfide. If the anion is a polyatomic ion, use the name of the polyatomic ion as given without the "ide" ending. You can find the names and charges of the polyatomic ions in your book as well. Examples of compounds containing polyatomic ions include SrNO32, which is named strontium nitrate, and Li2SO4, which is named lithium sulfate. For ionic compounds containing metals that form more than one type of ion, name the compound by joining the name of the cation, the metal, followed by the charge of the metal as a Roman numeral in parentheses, followed next by the base name of the anion, the nonmetal, with the ending I. If the anion is a polyatomic ion, use the name of the polyatomic ion. Notice that for these type of compounds, you must specify the charge of the metal. Why? Because these metals can form ions with different charges. For example, chromium can form a 2+ ion or a 3+ ion. You distinguish between these by naming the 2+ ion chromium 2 and the 3+ ion chromium 3. So, the name for the compound CrCl2 is chromium 2 chloride, and the name for CrCl3 is chromium 3 chloride. You can determine the charge of the metal because the entire formula must be charge neutral. Examples of compounds containing polyatomic ions include FeNO32, which is named iron 2 nitrate, and CuSO4, which is named copper 2 sulfate. Now, here's a practice question for you. What is the name of CONO3? A, cobalt trinitrate, B, cobalt 2 nitrate, or C, cobalt 3 nitrate.
Let's see what you guys are saying here. C. All right, let's give that a try.
The correct answer is C, cobalt 3 nitrate. Cobalt is a transition metal, and it's not one of those exceptions, so it forms more than one type of ion. Therefore, its charge must be included in the name. Since a compound contains 3 nitrate groups, and since each nitrate group has a 1- charge, the charge of the cobalt must be 3+.
All right, so we'll do some examples for this. All right, so before we get to that though, well, let's just do a couple examples. All right, how would you name that?
Magnesium.
Magnesium bromide. Yes. It is a lot of information. Let me show you what I'll have on D2L for you so it won't be quite so intimidating. All right. So as far as on D2L, when I get it put into a PDF, you'll have the flow chart that he was showing before. And then you'll have the little instructions on how to name compounds that form only one ion. And then how to name transition metal containing compounds. Actually, that should be naming compounds that make more than one ion, more than one charge. And then here's the periodic table that he was showing you in the video. It shows you all the different charges of the things that are constant. The only thing that's not mentioned in this periodic table that is important is that tin and lead, so Sn and Pb, those both make more than one charge, so they would need Roman numerals. Now, all the other ones that are highlighted, including number 21, scandium, number 47, silver, number 30, zinc, and of course aluminum, those do not need Roman numerals. And I have that written down here. So hopefully that'll help. Also, sometimes in the book it talks about main group metals and transition metals. So this is just a little periodic table to show you what a main group metal is. And then we've got the molecular compound stuff. And some stuff on naming acids, but we'll get to that in a minute. Correct. The prefix is only for naming molecular compounds. So molecular compounds would be things that have only nonmetals in them. So let me put that up. Prefix is for molecular compounds. Right? And then Roman numerals are for ionic compounds that have more than one charge. All right. Is this better, Kevin? Let's do some practice. Okay. So with these, you don't have to name them. I just want you to tell me, are they molecular or are they ionic? Okay. Yeah, as I'm typing, it doesn't show anything, and then when I hit enter, it pops up. So let's see. Let me give you a couple options. Molecular or ionic? Molecular. And the reason I know it's molecular is that carbon is a nonmetal and oxygen is a nonmetal. What about this one? It's ionic. And I know this is ionic because it's got a metal and a nonmetal. Right, what about this one? This one's ionic also, because I've got a metal and then I've got some nonmetals, but the nonmetals actually make an ion that it's called nitrate, NO3 minus. The 3 should be a subscript and there should be a superscript of minus. So I guess you could see it kind of like this. Let me see if I can make it look kind of normal. It's going to be kind of hard. Let's see. So kind of like that is what nitrate would look like. Let's see what else. This one is kind of tricky. This one is ionic. It looks like it will be molecular because you have NH4, and those are all nonmetals, and NO, those are all nonmetals. But this one's a little tricky because you have NH4, and that would be NH4 plus. Well, NH4. Let me see if I can do it like it would look. Okay, so that's NH4 plus, and that's called ammonium. Yeah, ammonium nitrate. Perfect. And then, so NO3 minus is called nitrate, and the other one is NO4 plus. Notice that when we're naming these, it doesn't matter what naming system we're using. When you have a polyatomic ion, you just say the name of the polyatomic ion. You don't change any endings or anything. It just stays the same. All right. Why is it ionic? That is a good question. So NH4 plus is an ion. It's one of the polyatomic ions. And NO3 minus is a polyatomic ion. So when you put them together, you get NH4NO3. And it's just made up of 2 polyatomic ions. So what we're doing is we're kind of taking the NH4 here and join up with the NO3 here, and then we get NO3. And because they're both ions to start with, they end up being ionic. it doesn't happen very often that you're going to run across something where everything is nonmetals, but it's ionic. This is pretty much the only thing that I can think of. But the other ones, just if you see a metal and a nonmetal, it's ionic. All right, let's take a look at naming acids. All right, so let's go up to naming binary acids. So when we're looking at acids, we're going to look for two things. First, an acid usually, not always, usually starts with an H. So, because if you talk about Lewis acids, they're different, but we're just going to go with this definition. If you see an H first, it's probably an acid. And then you're going to ask yourself a question. Is it made up of only two elements, or are there more than two elements? And so if it's only two elements, that binary acid. So that would be something like, they give you the example here of HCl. So it's hydrogen and chlorine. That's a binary acid. And HBr, that's hydrogen and bromine. So that's a binary acid. So how you name a binary acid, it has a prefix that's always the same, and that's hydro. And it has an ending that's always the same, which is acid. And the suffix is IC, ic. So it's hydro something ic acid. Always when you have binary acid. So you put the base name of the nonmetal in there. So for example, it'll be hydrochloric acid or hydrobromic acid. With iodine, it sounds a little funny, but it's hydroiodic acid. And let's see. All right, so that's how you name it when there are just two. Let me see. Give me 1 second. All right. So the next kind of acid we'll talk about is an oxyacid. So oxyacids are things that contain polyatomic ions, and those polyatomic ions have oxygen in them. That's what makes them an oxyacid. So these tend to have more than just two things in them. So they still start with an H. Now, for this one, we want to look at what is the polyatomic ion called. So if it's something that ends in 8, you put the base name of the oxyanion, change the 8 to IC, and put the last part is called acid. For example, nitrate ends in ATE, so we'll drop the ATE, replace it with IC, and then put acid on the end. So that would be nitric acid. And then if there's something that ends in ITE, there's also another compound called nitrate that has fewer, or nitrite, that has fewer oxygen in it. And it becomes, instead of nitrite, ITE, the ITE is dropped and ends in OUS. So it becomes nitrous acid. So let's see. So they give you this example here where if you look at C2H3O2 minus, that's acetate. So the 8 ending is turned to IC and it ends in acid. So instead of acetate, it's acetic acid. So what about the acids that end in OUS? Yep. So the ones that end in OUS would be things where instead of ending in ate, the polyatomic ion would have ended in ite. That is a good question. So that has to do with the polyatomic ion. So let me pull those up. Give me 1 second.